Neil says that because the numbers 1, 2, 3, and 4 are evenly spaced on a number line from left to right, like the one shown above, that 1 over 1, 1 over 2, 1 over 3, and 1 over 4 are also evenly spaced on a number line, but from right to left, as shown below. So we want to discuss here what ideas are correct, what ideas are incorrect in Neil's reasoning, and then correctly plot these numbers of 1 over 1, 1/2, 1/3, and 1/4. So in terms of talking about what is correct, um, one thing that Neil does have correct is the order of these fractions, right? So we know that the bigger the denominator, the smaller the fraction. So between these fractions, especially between 1/2, 1/3, and 1/4, 1/4 has the biggest denominator, which makes it the smallest fraction. So Neil is correct that putting those, 1 over 2, then 1 over 3, then 1 over 4, but instead of going, instead of going right to left, we would go left to right. I'm sorry, instead of left to right, we'd go right to left. So you can see that, 1/2 is the rightmost of those three, and then 1/3, and then 1/4. So that part is correct. And of course, 1 over 1 is really just the same thing as 1. But in terms of what is incorrect, so not all the ideas here are good. So when we look at the original number line, you can look at this and see that, the distances between these are each one whole, right? So like if I take 0 and add 1 to that, I get 1. If I take 1 and add 1 to that, I would get 2. If I add another 1 to that, I get 3, right? So they're all 1 apart. So the evenly spaced nature of this makes sense, and that's correct. When we look at this one though, I could add 1/4 to 0, right? 0 plus 1/4 would be 1/4 and would get me here. But then if I add another 1/4, that should actually be 1/2, right? Because 1/4 plus 1/4 is a half. So this spacing is not correct. And in general, these are not going to be evenly spaced, right? They are not one whole apart. So we'll look at how to correctly space those. So just for an example of these fractions not being evenly spaced, I just mentioned that the space between 0 and 1/4 is not going to be the same as the space between 1/4 and 1/3. So that's just one example. I could have used several other examples there, but just saying that that spacing really should not be the same. All right, so then how do I actually do this? Well, if I want to plot fractions on a number line, unless they are improper fractions, I'm typically just going to plot them all between 0 and 1. So I'm going to start just by putting some tick marks for 0 and 1 towards the end, but there's not really an end because it goes forever, but towards the end of what's visual here, what I can see. So then There's a couple ways we could do this. Like we could basically think of this like we would a fraction strip. And so like if I wanted to start with, for instance, the 1/2, because I technically already have 1/1, right? Because 1 is really the same thing as 1/1. So like if I wanted to take a strip and have a half from that, I would take that strip and split it in half. And so that would tell me where 1/2 goes. And then if I wanted to find, say, 1/3, I would take a strip and split it into thirds, right? Play around with that until I'm happy with it. And so that would tell me where a third goes. And so I could do the same thing with fourths and so on. However, what might be a better idea, especially if you have a lot of different fractions that you want to do, would be to find a common denominator. So if I want to plot a whole bunch of fractions and I want to make sure that they're spaced correctly, then let's get them into a common denominator and rewrite them in that form. So in this case, my fractions have denominators of 1, 2, 3, and 4. I don't really need to worry about 1 because 1 will go into anything evenly, but 2, 3, and 4, I'm looking for the smallest number that all of those will divide evenly into. And in this case, that happens to be 12. So what would make sense is that I actually split my number line up into 12ths, or if I was using strips, I would split my strips into 12ths. So to get 12ths, I'm just going to go ahead and split it in half, and then I'm going to do 6 on one half and 6 on the other. So I'm going to go ahead and split each half in half. So now I've got 4 pieces, and then I'm going to split each of those into thirds. And that should give me 12ths. And I'm going to just go ahead and label those as 12ths. 1/12, 2/12, 3/12, and so on. And so this is really, 12/12. All right, and so then I just find my equivalent fractions. So I know that 1/1 is the same thing as 1 or 12/12. So that's right here. And then 1/2 is equivalent to 6/12. And I'm going to go ahead and label these so that I'm showing that I'm actually plotting 1/2 and not just 6/12. So I'm showing that I know that equivalence. 1/3, that's really the same thing as 4/12. And I could simplify my fractions to find these, by the way. And then 1/4 is actually 3/12. So you can see here the difference between what Neil originally plotted and what we have here. The order's correct, right? So going from left to right, we had 0, and then we had 1/4, and then we had 1/3, and then we have 1/2, and then we have 1. But the spacing is definitely not evenly spaced. So like 1/2's in the middle between 0 and 1, and then everything else is to the left of that. 1/4 and 1/3 are really close together. Whereas the distance between a third and a half, and then the distance between a half and 1 are much bigger than that initial difference between 1/4 and 1/3.